Hi, I'm Donovan with another episode of Azure Friday. I'm here with Ralph in the second part of a three-part series on container native developer experiences. In this part, we're going to be talking all about Draft. Welcome back to the show.
Thanks very much.
So let's recap really quick. What is Draft?
Draft is a tool that you can use on any platform. It's open source completely, provided by the Microsoft developers that work on my teams that land container native iterative development in Kubernetes. And what that sort of means is that it helps you as a developer get out of just writing native code and then turning your attention to figuring out how to write a Docker file, and even more complex in many cases, how to configure all your containers into a logical service using a Helm chart, for example.
Got it. Okay, so why don't you show me how it works? Let's just jump right into it.
Sure, no problem. Well, we're on Ubuntu, over here, and we're going to be using a Ruby app. It's a very simple Ruby app, and we're in VS Code. So this is very familiar, and lots of people use it no matter where you are, no matter which operating system you are. So what you do in this case, we're going to test to make sure Draft is installed. You do that very simply. We're pointing at our Minikube local Kubernetes cluster.
So how does Draft know that we're doing that?
Because when you installed Draft originally, you installed Draft after downloading it by typing draft init. And, and it goes and discovers your kube config that you're currently pointing at.
Got it.
In this case, I was pointing at my Minikube because I just started it.
Got it. Okay, so Draft assumes that you're using Kubernetes, so therefore it's smart enough to say, I know that I'm going to go look for your config file, and in there is going to be all the information I need to know which cluster I'm supposed to be doing all my work against.
That's right.
Got it. Okay, perfect.
And it does have one dependency because, of course, it's a tool chain in the open source world. The dependency is Helm, which is commonly used for deployments in Kubernetes anyway.
Right.
So if it detects that Helm isn't there, it'll go ahead and let you install it first, and then it'll work fine when it gets installed.
Right. In the first show, we talked about Helm being an easier way to build the configuration file necessary to deploy into Kubernetes.
That's right. In fact, this time we're going to build our application here using Draft, and I'm going to show you all those artifacts that it creates.
Great.
Okay. So we just do draft create in this case. And it already detects, it uses the GitHub Linguist library to decide exactly what kind of app you have. It detected that we're running a Ruby app, and it said ready to sail. Interestingly, you notice that we got a few more files here. We didn't do anything about containment, but we know that a very simple Ruby app is going to be a web front end of some sort, and so we've given you an example Docker file that builds that app as a container already.
Got it.
If you know something special about your application, you can use this artifact as a starter container.
Okay.
Right? And elaborate some other environment variables or some other stages that you wish to do.
Well, let me ask you a quick question. So I see the Docker file that it created. I know enough about Docker to be dangerous, and I would have already built my own Docker files. What if I don't want you, whenever I call draft create, I don't want you to use this Docker file? How do I enable it to
We got the answer for you, but you're jumping ahead. So let's show this first, and also the Helm chart, because then we can take the step and answer your question more completely.
Cool.
So the other thing that it does, we did containment for you, but we also did service composition. In this case, a Helm chart we've dropped in. And in this case, a Helm chart allows you to decide how many replicas you want, for example, and some basic statements about the execution environment here. We want to say the external port should be 80 and the internal port should be 3000. And Kubernetes knows how to understand this and make it happen when it deploys.
Okay.
So here we've got our artifacts, and we didn't really have to know much about it. We can use them, elaborate on them, or we can actually give them to somebody else who really does know something and let them do that work for us so we can concentrate on the application.
Perfect.
So if we do that, the way to get it up, I try not to change the actual count. We do draft up because we've created the artifacts, and all we do is immediately take the kube cluster that we happen to be pointing at. We take the application and the containment and service composition artifacts, and we give it to the draft D, the service-side component in the cluster.
And then what it's going to do now is build the image inside of the draft instance that's running inside of my cluster.
That's right. Draft D is the name of the service. Yes.
Okay, and then it's going to then push it to a registry, which it looks like it's doing right now. And then after it's pushed to the registry, it can then deploy from the registry into my actual cluster and run it.
And in this case, it's the same cluster, right? It'll be Minikube.
Got it.
So we built the image. That didn't take too long, 19 seconds. It'll build faster as you iterate.
Right.
Obviously, we just push the Docker image to the local cluster. Now, what we do want to do is we want to see if there's anything running yet, because of course containers take just a second to come up.
Sure.
So if we do that, kget po. K is an alias for kube control here.
Ah, I see.
Right? You notice we don't really use kube control too much.
I was going to ask that because I remember when I first started learning Kubernetes, that's all I was typing was kube control, but you haven't done that yet. So who's taking care of all that stuff for us?
In fact, we're only using kube control here just to make sure that the containers actually started properly and so forth. And it looks like they're almost there. And when they are, we'll actually use them to make sure that our application is running correctly. But generally speaking, Draft collaborates with Draft-D and Helm in the cluster to do the deployment for you. As a result, you don't need to use kube control.
Got it.
It does not even have to be on your system in any way, shape, or form. You just need the kube config file.
Got it. So with a draft create and a draft up, I now have taken what was a native application and containerized that application.
That's right.
Perfect.
That's right.
But this is just running locally on my machine. This is not where the app's going to finally run. How do I then take the app from here and get it into a real cluster?
Right. Well, first you got to make sure you can see it.
Right. So that looks like it's...
So you use Draft Connect, and that'll create another tunnel. As we said before, the invisible RDP session.
Got it.
Right. And you grab the local host and the port, and you'll jump over to your Chrome or your Vivaldi or your Opera, and Hello World, I'm Ruby is there.
Perfect.
Right?
So now I
you know it's running, and it's also not running natively, it's running contained.
Correct.
And it's deployed in a cluster. And so you know that these container and cluster artifacts, the service composition artifacts, they work.
Right.
And so now you can push these into a CI/CD workflow.
Right, because now that I've seen that image work here, I know that image should work everywhere.
That's right.
That's the beauty of
And so let's try it, let's test that out. Right?
Okay.
Okay, so I've got, this is an alias for kube, for looking up your kube context, right? And I've got a few, and you can see that I'm in Minikube right now.
Okay.
But let's go to AKS East, and I do that on this machine with AKS East, and I've switched to AKS East. And if I do get po now, there's nothing in the cluster. It's a brand new cluster. And is draft installed? I can find out by doing draft version. It says yes, there's on the client and the server, and I've got the same version, so I'm in great shape here.
So for those of us who don't know what AKS stands for.
AKS is the Managed Kubernetes Service in Azure.
Perfect.
And it's a great way to move from a fully managed solution, because Kubernetes is relatively recent, and most people early on had been building their own clusters.
Right.
Or in using, for example, ACS Engine in Azure, which literally uses ARM resources collectively to build your own cluster. But you manage the entire cluster.
Sure.
Right? And so the AKS service is where Azure platform offers you the service of managing your master nodes in your cluster.
Got it.
And that means you actually trust us. We give you the features to upgrade, to scale in, scale out, all those things you would normally do with the masters. We'll handle for you and give you an SLA on that. It's
nice.
in preview now, and it'll go GA relatively soon.
So that's just one less thing for me to have to worry about.
Absolutely. And you can concentrate on your applications and your operations, which is what you really want to do anyway.
Okay.
So we've got this all, we've got the same artifacts going, and we're pointing at a different cluster. Let's just do the same thing and point at a different cluster.
Got it. So we switched from our Minikube to the actual cluster we're going to run in.
Yep.
You verified that it's not there currently, because when we tried to access it, it said no resource was found.
That's right.
And now what we're doing is we're building the image again, but this image is now going to be pushed to a different registry?
A different registry. In this case, I've already created, when I installed Draft into this cluster, I gave it the credentials to use the Azure Container Registry.
Okay, so we stood up our own registry in Azure, and we've configured the Draft that's running inside of our real cluster to be able to authenticate against that register and push and pull images from there.
That's right.
Got it. And that's exactly, so once this image is built, we're then going to push it into ACR, and then from ACR into our AKS.
That's right.
All right, perfect.
And this took a little bit more because we had to pull it for the first time, the images
Sure.
and so forth, but not too long. And now we're pushing the image into ACR.
Got it, right. Of course, because you have to download all of the different layers, and once you have them cached, it's faster. And obviously, we have them cached on our local machine because we've been doing development. And here, it still didn't take quite that long.
No, it
So
didn't
now we
take
still
that
have to go back and confirm that this is actually running again.
That's
correct?
right. And you do the same commands. Connecting to your app, we've created the invisible RDP tunnel. Whoops, I broke out of it. That's my mistake, because I need Control-Shift-C.
Gotcha. So again, even though it says localhost, this is actually running in a publicly available AKS cluster in Azure.
Right.
Okay.
So we do this, and we're going to get the same result back.
So if I knew the IP address of the service that's being hosted inside of Kubernetes, I could actually put that IP address there and get the same results as I'm getting now.
That's correct, as long as you had created an ingress for that cluster.
Got it.
So in other words, normally this endpoint is exposed as a cluster IP type, and what that means is the endpoint that it's hosted at is only visible within the cluster, and that's why we create a secure tunnel to the cluster in order to view the endpoint.
Perfect.
Okay?
Great.
So here's the problem, though, and I think you're going to go there right away, I bet. This is a very simple app, and most apps are going to be very customized, either because they have odd things in them that are non-standard, right? Or because you're maybe running in an environment like in a corporate environment where you have special types and special application frameworks you built yourself.
Right.
And you can't really guess using Linguist how to do that.
And also I might want to control what base images you're using in my Docker files. There's all sorts of control that I might want to put on here that I don't want some generic hello world, happy path Docker file that this thing is producing for me.
Dern tootin', as my mother would have said. In this case, let's go to a really strange app. It's actually not that strange. This is an F# app that is designed to be built with the .NET Core 2.
Okay.
All right? And it uses the Giraffe open source MVC framework, which is it's an open source framework that sort of cuts out a lot of the stuff that ASP.NET put in for MVC just to streamline the operations, and it works perfectly with .NET Core.
Okay.
Right? So this is a pretty odd combination of apps.
Yeah, for sure.
How are we going to be able to guess what kind of container, what kind of Docker file to use, and what kind of chart to use in order to deploy this? Well, we can't guess. But in this case, you actually built this application, or maybe your dev lead did, or your architect, and they know how to contain it.
Okay.
So you don't want to do that. You just want to work on your F#.
Sure.
So what you do in this environment, as we'll get our prompt back, we're going to say draft create and pass a custom draft pack. And this is where you can create a repo, both public or private, that contains these containment and service composition artifacts for specific or private applications.
So when you ran draft create earlier, I saw it created a folder for our chart. It created a Docker file and some other artifacts. Those artifacts are now been defined in this package to meet all of our specifications, such that every time I do this, I'm going to get those Docker files and those artifacts out automatically.
That's right, and you can check the repos you have there by doing draft pack repo list. You can see that I have my own special draft pack repo that knows how to configure this very odd application.
Perfect.
And this happens to be odd. I'm using that as an example, but it might just be within the corporate firewall.
Sure.
And you just don't want to share these kinds of things, right?
Right. Perfect.
So in that environment, we're going to do draft create, which is the same experience, but we're going to do the draft pack specific. And you'll see that we get the same files, but now they have a very customized container core. If you're a developer and you really know what you're doing, or maybe you're the dev lead or the architect, as I say, you might even continue to iterate on this artifact.
Sure.
But it's now part of the build environment and the development environment for whoever. If you had 10 developers and they all need to collaborate, they just say draft create with a pack, and then off they go.
Yeah, this is a bootstrapping exercise. This isn't something that you run over and over again.
Nope.
You produce the Docker file by using the draft create. You can then go modify this Docker file to your heart's content. It was just a bootstrap you can get you going. And then you're going to start committing this into your source control with the rest of your artifacts, and then run it through whatever CI/CD pipeline you want to run it through.
That's right. And once these artifacts are in source control, now the operations team can have a hand in it.
Absolutely.
You can version them, put them different versions in different branches, and so on. So now your whole artifact and creation process is all controlled by the kind of systems that are designed to do that work.
Absolutely, yeah. I just wanted to make sure, because when I first started looking at drafts, I was like, well, when do I run create? How often do I run create? And it's very clear now that it is something that you run once for the project to bootstrap it, and you don't have to run that anymore. Now, I might be running draft up all the time.
Sure.
Right, but
you would iterate.
Exactly. Okay, perfect.
Right. And all up would take the artifacts and build the image and do the deployment as you've just seen here.
Perfect.
Okay? So if we wanted to do this, we would do the same. We would have the same experience here, draft up, right? And now it's going to go through the same process here. Now, in this case, this application, and we might actually edit this a little bit for time because this application has more artifacts. It's a little bit more complex. So the first time we do this, it probably will take a little bit longer, maybe 100 seconds or whatever to cache the images and so forth. But once they're there, then the iterative time will be very, very rapid.
Right. It's the same experience we'd have with any Docker development at this point.
That's right.
But it's really nice to see that I don't have to be a Docker file expert, which I felt like I had to learn to get started. I kind of wish I had procrastinated a little bit longer to get to Docker, because now we have the tools like this for the open source world. We have those great tools inside of Visual Studio that basically does all this magic for you as well.
Right.
But I got in just a little too early because I had to do all this stuff myself.
Yeah, I'm sorry. That's really our fault. Yeah, we were a little slow on that one.
but it's great to see what it does.
This stuff works everywhere too. I mean, we're using Minikube here, and then we repointed toward AKS.
Absolutely.
Right? But it'll work in any of our fantastic competitors. It'll work in bare metal clusters. It's open source.
Yes, as we talked about in the first show, and we showed, I believe here, is that there's a repo that you can go and see how we've done all of this. You can contribute. It's just a full open source project.
Fix bugs that you find, add new features.
Fantastic.
Come and join us and participate.
Fantastic. Well, we are learning all about Draft here on Azure Friday.